The marvel of medicine. A doctor prescribes a dosage of 500 milligrams of medicine to treat an infection. Each hour following the initial dosage, the concentration decreases by 20% from the preceding hour. Number 1. Complete the table showing the amount of medicine remaining after each hour. As you see from the table, starting at 0 hours, we have 500 milligrams. At 1, we have the 500, but then we have to multiply that by 1 minus 0.2, which we got from the 20% that's decreasing every hour. That gave us 400. When we repeat the process for number 2, we'll get 500 times 1 minus the 0.2, and then we have to multiply that by another 1 minus 0.2. As you can see, the process repeats itself down through the table till we get to number 5 for 5 hours, where we've repeated the multiplication 1, 2, 3, 4, 5 times to come up with the 163.84. Number 2, using symbols and words, describe the functional relationship in this situation. Discuss the domain and range of the function rule and of the problem situation. Does this situation represent exponential growth or exponential decay? Explain your reasoning. So for number 2, we can use our TI Inspire calculator. We have the amount of medicine remaining in the patient's system is 500 times the rate raised to the number of hours. The X values represent the number of hours the medicine is in the patient's system. A scatter plot may be used to analyze the data. Press Home, press 1 for New Document, choose No, and press the click. Choose Lists and Spreadsheets. On Lists and Spreadsheets, label X on the label A and label B as Y. Input X values from your table starting at cell A1. Input Y values from your table starting at cell B1. As you can see, you put in your table values. Here is for X, and this is where you put in the Y values. To create the scatter plot, press Menu, press Data, and then press Quick Graph. You should see what is shown here, where we have a spreadsheet on one side and a scatter plot on the other. You must choose the corresponding values for the axes. On the bottom, choose the x-axis, and on the side, choose the y. Now we end up with a nice scatter plot. To determine the regression from a scatter plot so that we can come up with the exact function or the equation, we're going to go to Menu, Analyze, Regression. Make sure that you choose exponential, and then the equation will show up and you should get 500 times 0.08 raised to the x power. How does that compare with the equation from the table, which was the 500 times 1 minus 0.02 to the x? The domain of the function is set of all real numbers, but the domain of the problem is a set of non-negative numbers, which means where x is greater than or equal to 0. The range is the set of all numbers less than or equal to 500, but greater than 0. For question number 3, describe how to determine the amount of medicine left in the body after 10 hours. The calculator can be used to explore the amount of medicine left in the patient's system after the different number of hours. If we go back to our equation, y equals 500 times 0.08 raised to the x power. If we know that we're asking for something after 10 hours, we can plug in the 10 for the x. When you do that, you end up with 53.6871 milligrams of medicine left in the patient's system. For number 4, when will the amount reach 60 milligrams? Explain how you know. From the same table values, it can be seen that the patient will have 60 milligrams left in his system between 9 and 10 hours after initial dosage. For the exact value of numbers of years, you will need to use your calculator. Let y equal 60 milligrams of medicine. The equation should be used would be 60 equals 500 times 1 minus 0.2 raised to the x power. When you do that, it comes out to 9.50179 hours for the medicine to go down to 60 milligrams. Number 5, why would it be important for the patient to repeat the dosage after a prescribed number of hours? A patient would need to repeat the prescribed dosage to keep a constant amount of medicine in his system to fight the infection.